Hello, Algebra 2 CP students. Hope you're having a great day so far. Another late night recording, as you could tell by the dark background behind me, the fact it's already pitch black outside. But regardless of the time of day, it's always Algebra 2 time. And speaking of which, I would like you to get started with a couple problems here on solving by factoring. Just going off of what we talked about yesterday, if you were in class or watched the video, or maybe you did both. See if you can solve both of these quadratic equations by factoring. Of course, set the problem equal to 0 first and then try to break it down. Take about 5 to 6 minutes to see if you can do that on your own, and pause the video, unpause when you're ready to keep going. Take that time, try to do these two problems. So by now, I take it that you've paused, tried these problems on your own. We're going to go over them really fast. And then today, I'd like to show you a couple additional cases or a couple additional things that can occur when solving quadratic equations by factoring. Namely, if you have a greatest common factor involved, if we have to take out a GCF, or if we actually have no constant term. What do we do? We're going to figure that out. So starting with a problem like this, right? What I would do first is, of course, set equal to 0. I'm going to add 10x to both sides. Notice how I write that plus 10x in the middle there. That's sort of a reminder for me to say we want to write everything in order, in our nice descending order, our standard form here. We have 3x squared plus 10x minus 8 is now equal to 0. And now that we've set the problem equal to 0, we can go ahead and factor it as per usual. So we're going to break down our trinomial into its factors. We know that in order to get 3x squared, it would be this term times this term. And the only possibility to get 3x squared, which is nice for us, that's 3 times 1, right? 3x times 1x. I know that these last two values have to multiply to equal negative 8. So the fact that it's negative means we need one of each sign, right? One positive and one negative. That's the only way we can multiply to a negative value. And given that we're adding to this positive 10x in here, it probably makes a lot more sense to put the positive sign here and the negative sign here. It's not guaranteed, but it makes more sense to do that because it's going to pair with the bigger multiplier, right? Doing 3x times something times a positive thing is going to work us closer to that positive goal than just 1x would, right? So it makes more sense to pair the 3 with the positive because we have a positive goal in the center. Not a guarantee again, but just gets you off to a good start. And now we're looking for numbers that would multiply to give you 8, that when we combine give us this 10x. We could use 8 and 1, or we could use 4 and 2. And if you messed around with your factors, you would see that we put a 4 here and a 2 here, and that would work out just fine, right? Because we would have 3x times 4 would be 12x. Negative 2 times x minus 2x. 12 minus 2 is 10. Okay, so this would be the factored form of that. And now we just have to solve the equation by splitting these apart. Because we have two things being multiplied together to equal 0, we can say, well, let's find a value for x such that 3x minus 2 is equal to 0. Because if we can make this piece 0, then who cares what that is? It's just going to equal 0 because 0 times anything is 0. And likewise, we could do the same with the second piece as well. Find a value for x such that x plus 4 is equal to 0, because again, if you make one of these pieces 0, then who the heck cares what the other piece is, because 0 times whatever will equal 0. Alright, so that's why we're able to use the zero product property and split into two separate equations like that. And now we just go ahead and solve their little baby Algebra 1 problems at this point. Add 2 to both sides, we would get 3x is equal to 2. Divide both sides by 3, and we'd start with x is equal to 2/3 as our first solution. It's okay that we got a fraction, no problem. And over here, one step, subtract 4 from both sides. Our other solution is x equals negative 4. So those are our two solutions for this problem. Okay, hopefully that made sense. We'll jump right into the next one as well. I think the second problem looks a little intimidating at first glance because you see a lot of terms everywhere. But once you move everything to one side and combine like terms, it actually gets significantly less scary. So what I would do is, again, we want to try to make the coefficient of x positive. That's kind of what I talked about the other day. I think that just saves work in the long run. So rather than add 7x squared to both sides, notice that would make this negative 1x squared. I would instead choose to add the 8x squared to both sides because that'll make this positive 1x squared. That's just going to save us work in the long run, so let's do that. I would add 8x squared to both sides. I would also, and that gets rid of that, I would also subtract 4 from both sides. notice that's going to pair with the other constant, right? We're not going to combine it with something that has an x in it, because, again, that's going to help set the equation equal to 0. That gives me 1x squared plus 9x, that was unchanged, plus 8 is equal to 0. I forgot to cross that out over there. So see how that looked really scary at the start, but then when we started shuffling terms around, it ends up at a fairly easy factoring problem, actually, because now we would factor as usual. Notice in order to get 1x squared, we just need regular old 1x times 1x. Everything's positive, so no reason to introduce any negatives. And we're looking to see how we can multiply to 8 when I do this times this and this times this, and add to this 9x in the middle. I'm going to use 8 and 1. Because notice this would be 1x, this would be 8x. Together that makes 9x. Since 1 and 8, or since x and x are both the same, you could choose to put the 1 first and the 8 second as well. That's totally fine. All right. And now, again, we have two things multiplied together to equal 0. So if we can find a value for x such that x plus 8 is 0, that's pretty cool. Or if we can find a value for x such that x minus 1 or x plus 1 would be 0, that works too. Obviously, only one step here. We get a solution of x equals negative 8, because negative 8 plus 8 would be 0. Or x could equal negative 1, because negative 1 plus 1 would be 0. Not too bad, hopefully. Making sense? This is good. Now, like I said, I want to today talk about two more cases that haven't yet come up, or two more little twists on these type of problems. The first of which is, what if you have a greatest common factor going on here? By that I mean, consider a problem like this. If I have 4x squared minus 40 is equal to 6x. Okay. Before you take a greatest common factor, you could clearly see here that these all have a greatest common factor of at least 2. This time it is in fact 2, but knowing that they're all even numbers, you would say, oh, there's definitely some sort of GCF going on here. Before you worry about a greatest common factor, always, 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 step 1 is to set equal to 0. So before we even think about GCF, I'm going to go ahead and set equal to 0 by subtracting 6x over to that left side. That gives me 4x squared minus 6x minus 40 is equal to 0. Now that I have everything on one side is all equal to 0, again, all nice and in descending order, now we can think about a GCF and pull out a factor of 2. It's going to hang on the outside, gives us 2x squared minus 3x minus 20. Notice that just helps not only reduce the numbers, making factoring easier, it also reduces the number of possibilities. Now when we break things down, I'm going to keep my 2 on the outside here. Say this equals 0. We're going to factor our middle piece just like we're used to doing. We have, to get 2x squared, we need 2x times 1x. Notice I'm kind of going through the factoring steps a little faster at this point. If you do need a refresher, I recommend going back to watch the factoring video. Here, let's see. I'm multiplying to negative 20, so we need one negative and one positive. Probably makes sense to put the negative here, so because our goal in the middle is negative, but we'll find out. Now, what combination is going to work in order to get negative 3? Well, we could do 20 and 1, we could do 10 and 2, or we could do 5 and 4. And I think 5 and 4 is the one that ends up working out, correct? Because if I did, let's see, if I did, if I did 4 here, there it is, and 5 here, had a little brain lapse for a moment. I was like, does that actually work? It does. Because this would be 2x times negative 4 would be negative 8x. 5 times x would be positive 5. Negative 8 plus 5 is negative 3. All right. So now that we factored successfully, now we would say, again, we have two pieces multiplied together to equal 0. We could say, well, if we can find a value for x that makes this piece equal to 0, we'd be happy. If we can find a value for x that makes this second piece equal to 0, we'd also be happy, because 0 times anything is 0. A lot of students ask, and it may be a question that's already on your mind, what about this GCF of 2? Does that do anything? Does that factor into our answer? The answer to that is no, it doesn't. And the reason for that is because think of if you took this whole side of the equation and divided by 2, right? If you divided all of this stuff by 2 and divided this side of the equation by 2, the 2's would cancel out, and 0 divided by 2 is still 0. So when you pull out a GCF that's just a regular old number, just a constant like that, it's not going to affect our solutions because, again, making this bit 0 and then multiplying it by 2 still results in 0. All right? So it doesn't affect our solutions. It really just makes factoring easier. Now, if we pull out a GCF that's a variable, that's a different story, which you're going to see in a little bit, because then we would have to consider this as one of our pieces. All right, but you'll see that in just a moment. So now that I'm proceeding with this problem, again, just algebra 1, I would subtract 5 from both sides to get 2x equals -5. Divide both sides by 2 to undo that multiplication and get our first solution of x equals -5/2. Other one over here is now one step. We're going to add 4 to both sides and get x equals +4 as our second solution. All right? Hopefully that made sense. Now, the reason why I think it's important to not take the GCF until you combine like terms is because until you move everything to the same side of the equal sign and set equal to 0. The reason why is because sometimes that GCF won't actually emerge until that point. Consider a problem like this. If I had 13x squared minus 40 is equal to -2x squared plus 10x. Think about that. If I look at that at face value, you may say to yourself, oh, this kind of looks like it may have a GCF, especially with like a 13x squared. That's a really big number. But right off the bat, you can't really take one. Nothing has a GCF here until you combine the like terms. If I add 2x squared to move it over to the left side and subtract 10x to move that over to the left side as well, we would get that this comes out to be 15x squared minus 10x minus 40 is equal to 0. And only then does the greatest common factor emerge, that greatest common factor being 5. I take out a GCF of 5. We're left with 3x squared minus 2x minus 8 is equal to 0. All right, so hopefully that makes sense as to why we want to wait to take out that GCF, because sometimes it might not even show up until all those like terms are combined. Now that we did that, though, it's really going to play out very similarly to the problem we saw on the left side here. I'm trying to break down my factors, set equal to 0 like that. We have 3x squared here. That means we need 3x and 1x to make that occur. We have a negative here. That means we need one positive and one negative to make that happen. I think it probably makes sense to pair the negative over here and the positive over here because we're going to a -2. But let's see how it plays out. Possibilities for 8. We have 8 times 1 and 4 times 2. And I think I kind of see it right now. If I do the 2 here and the 4 here, do you notice that this is going to be 3x times -2 is -6x plus 4x. That's going to be our -2x in the center. Just like the previous problem, we now have a couple pieces being multiplied together to equal 0. We're going to split them apart just like we did last time to say, well, when is 3x plus 4 equal to 0? When is x minus 2 equal to 0? This is equal to 0 when, let's see, we get 3x equals -4, divide by 3. I would get x equals -4/3 for my first solution. Again, okay that it's a fraction. Add 2 over here. We get x equals 2. So those would be my two solutions. All right. So again, when you have a GCF, just make sure to wait until everything's on one side of the equal sign. Wait until it's set equal to 0, but then always try to look for one because it does make your factoring step significantly easier. All right. Last thing I want to show you is what if we happen to have a missing term? By that I mean if we happen to have a missing constant term or maybe even a missing x. What do? Do we cry and give up? No, we keep going. We can do what we need to do. All right. So consider a problem kind of like this. If I had x squared minus 8x is equal to 0. Well, in this particular instance, you might say to yourself, wait a minute, I'm missing the constant. Isn't it supposed to be x squared, x, and then a number? There's no number here. So we can't do our factoring with trinomials as we're used to. But in fact, this problem is even easier than that in that we would just take a greatest common factor. Here, we have a greatest common factor of x. So I would just take that greatest common factor and pull it to the outside. That leaves us with x minus 8 is equal to 0. And once again, although it doesn't look like the two sets of parentheses we're used to seeing, we still do have two pieces multiplied together to equal 0. And so we split it apart just like before, and I say, well, what value for x, if I plug it into that first piece, would equal 0? Since it's just x alone by itself, we would just say that x would equal 0. Because notice, if we plug in 0, that would make this first piece equal to 0, and 0 times anything would be 0. And over here, we just treat this one just like before. I say, when does x minus 8 equal 0? We would add 8 to both sides. We get x equals positive 8. So a lot of times, these problems show up as quote-unquote easier problems, but a lot of students actually get them wrong because it doesn't look like a familiar form. But in fact, this is significantly faster than the problems that we've done that have all three terms, because all you have to do is just take out that greatest common factor of x, and now you have your two pieces right away. All right, so don't get tripped up on something like that. It's not a trick question necessarily. I feel like a lot of students think it is because it's different, but it's different in a good way, different in an easier way, different in a faster way. Likewise, if I have the same thing with just x squared and x, but suppose they're on opposite sides of the equal sign, kind of like that. Well, what I'm going to do is I'm still just going to move everything to the same side of the equal sign and treat it exactly like that over there. Watch. Before I deal with this, I would add 7x to move that over to the left, and I'd get x squared plus 7x. Take out that GCF of x, and go from there. A lot of students, and I just want to make sure I point this out, a lot of students look at this problem and they make the mistake of saying, ooh, we have an x over here, we have an x over here, let's divide by x on both sides, divide by x, cancel out the x's, you get x equals negative 7 and call it a day. Well, first of all, that's really, really bad, because what you're doing by dividing out the x's is you're eliminating one of the possible solutions. We need to make sure we grab both solutions here. You would eliminate the 0. Second of all, there's no guarantee. We can't divide by a variable generally because there's no guarantee that x is not 0, right? So if we were to divide and the variable happened to be 0, we'd be dividing by 0, which would be very bad. Okay? So in short, if you see things on different sides of the equal sign, just like with our trinomials, we're just going to move them to that same side first. All right? Now that I have that, as I mentioned before, take out that GCF of x. We have our two pieces now. One piece times another piece is equal to 0. We'd get x is 0 from this piece. And just to do a little shortcut, x equals negative 7 from that piece. Okay? Last but not least, how about an equation like this to kind of bring it all together? Ready? 3x squared minus 75 is equal to 0. How about that problem? Now we don't have an x in there, but is that an issue? I mean, it's a kind of a weird, it's different, but it's not necessarily an issue. We can still take a greatest common factor, just like before. That greatest common factor here would be 3. Now leaving me with x squared minus 25. And once you do that, you kind of get that little tingly Algebra 2 feeling where you're like, ooh, wait a minute, x squared minus 25, that's a difference of 2 squares, just like we've seen before. Difference of 2 squares is certainly fair game to show up with problems like these. And we could say, well, we know that we can break that down to be x plus 5 and x minus 5. Because x squared minus 25, that's difference of 2 squares. The square root of x squared is x and x. The square root of negative 20, or square root of 25 is 5 and 5. We have 1 plus and 1 minus. All right. You can also think of this, if it's helpful. Let me make a little note over here. You can think of this, if this is helpful, as if you forget the little shortcut with difference of 2 squares, x squared plus 0x minus 25, and treat it like your trinomials and say, well, we're trying to break this down. We need x times x to multiply to x squared. We're multiplying to a negative, so we need 1 plus 1 minus. And now we're trying to find factors that equal a 0x in the middle. Well, if I did plus 5x and minus 5x, that's going to give me 0x. Okay? So whether you remember the shortcut of just taking the square root here and here, here and here, 1 plus 1 minus, or you could treat it like one of our trinomials and go about it that way as well. okay, with just a 0x in the middle because there's no x's. So regardless, though, of how you approach it, we end up with one piece times another piece is equal to 0, giving us one solution of x equals -5 and one solution of x equals +5. So those would be your answers for this problem. Alrighty. Hopefully that made sense. Hopefully we're all square on solving quadratics by factoring. Just to do a little recap for you, we did a couple problems like we saw last time at the start of class. Over here, we saw what happened when we need to take a GCF. Make sure you set equal to 0 first for reasons that we saw over here. And then if we're missing a couple terms, feel free to just take out a GCF of x. You have your two pieces. Move everything to the same side. Take out a GCF of x. We have our two pieces. And be on the lookout for difference of two squares. That's certainly a fair thing that can show up. We'll have a couple of practice days in class. So we have Thursday and Friday to practice. Next Monday, we'll kind of wrap it all up, and we'll have a progress assessment before we break for Thanksgiving. Thank you so much for your attention and focus today. Appreciate that. I hope you have a fantastic rest of your day, and I will see you next time.